just finished sound. Let's talk about sound for a little bit, and then we'll compare the two with light. Okay? So how does sound travel?
Sound travels like really kind of fast.
Okay. Good. All right. So under this, in this box right here, we're gonna write compression waves.
Josh. Josh, look at me. Just listen and I'll write for you. Okay, just turn around and listen.
Is that better? Yeah. Compression waves,
Peace.
What did a compression look like? What were the molecules? How are the molecules arranged, Austin?
Compacted together.
Right. So let's do this. We'll do them really compact together. What? White wave, white wave. Your spoon is really big though. You should have one. Write it down. And then what was the other part of the compression wave where the molecules were spread apart? What was that called, Peyton?
Rarefaction.
Good. So let's draw spread apart. And then let's draw another compression wave. Sound. The speed of sound. What does it depend on?
Oh.
And what three types of matter did we test in our experiments? What transmitted sound the fastest? Eli. And what transmitted sound the slowest? Josiah. Good. So let's write up here. Depends on matter. That's right, depends on the type of matter. And underneath, fastest through solids, and then slowest through what?
Gases.
Good. Slowest through gases. Can you read that?
You can.
We have depends on the type of matter. Depends on the type of matter.
What about Mikey? Oh yeah.
Oh yeah, we showed Mikey our sound wave traveling
We should do that
through a solid
again.
liquid and a gas.
That was fun.
You got it? Slowest to quickest.
Slowest through gases.
Yes, that's the best way. Slowest through gases. Thank you. Alright, go down to the box below. You can still see it. I'm not going to move it that far. And it says, what happens when it hits a solid, liquid, or a gas? And this is when Miss Lindsley led the center where the timer was on one end and then your ear was on the other. There was a cushion. What happened when the sound was going and hitting the cushion? Mikey?
It bounced through the other tube thingy.
It did?
Well, some.
Some sound, but most of it was what?
It was absorbed.
Absorbed. Good. So we're going to write absorbed. Oops, I was going to write with pen. Oh, you can see that much better, right?
Yes.
Can you see that?
A lot.
Good. And then in parentheses, you can write soft cushion. To remind you. When we hit the tin foil and then that white board. Chrissy.
The whiteboard, it bounced off of it.
Slowest. So we're going to write bounced off, or you can write reflected. I'm going to write reflected. And then let's write hard surface. In parentheses. That shows up so much better.
Just right. Thank you. Move on. Yeah.
All right, good. So the two things, absorbed and reflected. Now what can you tell me about light? Do we already know how light travels?
Yes. No.
What were the two things that we filled in on our sheet? It travels 2 words. And then we'll add some more later. Devin. Good. So write fast and straight at the top. And then we'll come back and we'll fill in some more a little bit later.
Give her your paper to copy. Give her your paper to copy. Give the city your paper so she can copy.
We're going to fill in the next 2 a little bit later, and then the last one we'll fill in later on in our unit. Are we good? I'm going to turn this off. Okay.
Oh, no.
Okay?
I love these.
What do you think this is?
Oh, I know this. Oh. I know it.
Go ahead, Ethan.
A bow and an arrow shooting into a target.
Okay. What else?
The Hunger Games thing.
Oh.
Well, let's see. Is that a better clue?
Yes.
The Hunger Games.
Yeah.
Mockingjay.
Alright, the next one. Wow, what could this be?
That's
Oh,
hard.
it's just a big red square.
Just simple.
Referee soccer card? Could be, I don't know.
A cherry.
A cherry could be.
A president.
Could be, I don't know.
Cardinal.
So far, no one's guessed it. Do you want another clue?
Yes.
Yeah.
Oh my gosh, I was seriously gonna say that.
What?
The target?
Yeah.
I was gonna say that.
The Target emblem. Now, some of you might
Oh, the store.
dislike
Target.
or really, really like the next one.
Oh, is it
Target
Target?
4.
No. Are you ready?
He was at
Okay, that's a. Oh, okay, that's a.
Wait, let Landon.
I think you should let Landon.
Let Landon.
Pienso, what do you think this is? No?
Oh.
Oh.
Snassy and using.
You.
No?
Oh. The UNC symbol.
Let's see. Let's zoom out.
Oh.
Is that a better? You want? Can you zoom it out one more time? Felicity, what do you think? Yes. There we go.
Tar heels.
All right. How can I see?
Oh, I know some of the moves.
How can I see these pictures? How can my eyes see this?
You just guess.
Just
Oh,
guess.
the light.
Mikey, what do you think?
Because of your brain.
Okay. What if I did? If I did this, why can't you see that anymore?
Because it's off.
There's no light coming from where?
The projector.
The projector. Inside the projector is a light bulb that is showing the picture on the screen. Does that make sense?
Yeah.
So when I cut the light bulb off, you can't see anything anymore, right? That'd just be like if I cut all the lights off in the room, you couldn't see anything. That makes sense? So light reflects off of objects in that so that we can see them. Does that make sense?
Yeah.
Yes. Okay. What? You get it all right. All right. So you can probably guess what our next unit is going to be. Good. Tell me what you know about light so far. With your hands. Gracie, what do you know about light so far?
It is a source of energy.
Okay. Good. What do you know about light?
If you were to go to the sun and you touch it, you'd be dead. Like, then.
Good to know. Devin, what do you know about light? It can travel around the earth 7 times. Austin, what do you know?
When you turn on the light, it's blinking, but you can't see it.
Okay. What do you know, Chris?
Light can be used to power objects by solar panels.
That's really good. What do you know, Josiah?
They're really different colors, but even I can't see it.
We'll get on that later. Is that what you're going to say? What do you think?
That if the sun burns out, we'll have 8 minutes of light before all the lights come.
Oh, because it
It takes time to
8.3.
travel.
That's really clever.
Bam!
What do you know about light? Light is a form of energy. What do you know?
Light is faster than sound.
Good. Great. I was about to call you Gracie. Rachel, what do you know?
Light travels fast and straight.
Very
Good.
good.
Anything else?
Light is also heat.
Okay.
Light can travel through objects.
Okay. What do you mean by that?
Like if you were to put a glass up to like one of the fluorescent lights, it'll shine through.
Okay. Josiah?
Light can bounce off of stuff like
Mirrors. Like mirrors. Did he finish your sentence? What do you think? What do you know about light so far?
Those lights aren't actually white, they're like different colors of like they're white.
Say it again.
That isn't actually white, it's like red
Okay. What do you know?
you can mess with like you can bend it and like fix it.
Good. One more thing.
If you stare at light the whole day, you'll become blind.
Probably. All right. Let's talk about light for a little bit. what is light? What is light? A form of energy that
our eyes can direct.
that can detect.
Oh,
Thank you.
I directed them.
Light does not need matter to travel.
Right. Okay. How does light travel? Do you know? Well, we talked about fast and straight. There's a T word up there.
Light travels in waves called transverse.
Transverse waves. Yes, not like compression waves when we talked about sound where the molecules are bumping each other. Light travels in transverse waves. Everyone say transverse.
Transverse.
Good. All right, I need a volunteer. Jonathan. Yeah. I just need one right now.
She just wants to be okay.
If she's gonna do that, then I'm glad I didn't come up there.
All right, stretch out.
Jump rope.
Okay. One group at a time, I'm going to call you to come up. Don't step on the rope at all. I don't want you to step on it. I want you to be able to see what a transverse wave is. Group 3, come up. Just kind of form a circle. A little too close. Back up. All right, group 6, come up.
Oh, yeah. Are we jumping?
No, we're not jump roping or playing tug of war or anything. 2, come up.
You want it?
No.
Oh, man, I was going to say I'm still with this.
I need some room to move the wave.
Oh, playing a wave.
I can't see. Group 4, yes.
Oh, no, you're going to
It
hit
won't hit you. Alright, group 1 come up and group 5 come up. That'll probably be better. There we go. Alright, walk down a little bit. Can you peek anything? Can you see it? Alright, bend down. Alright. This is what a transverse wave looks like. Like this. Oh, don't move yours. Can you back up just a little bit so it can be tight? Perfect.
Make it
okay,
fast.
See?
Oh, ow. Well, she told you you need to
Okay. I just stopped the wave. What is this part?
Compress.
Yes. When we talk about light, it can also be called a peak. Everyone say peak.
Peak.
Is the same thing as
Crest.
crest. What is that over there? What's the trough? And how do we remember that? Pigs have to bend down and eat out of the trough, right?
Yeah.
All right. So this is a transverse wave, unlike a compression wave. Do you remember when we did the slinkies?
Yes.
When we pushed the slinky and you could see the parts where it was really close together and then the part that it was spread apart?
Yeah.
This is a little different. Okay? All right, you can go back to your desk. Thank you, Jonathan. Alright, let me turn this back on. Okay. There are also a couple different ways light can travel. They travel in transverse waves, but they also travel in rays. Have you ever heard that word before, a ray?
Yes.
Where have you heard that word?
In math.
In math? What about in math, Chrissy? Okay, what is it? So, let's see. Let me pull this up. So, does a ray look like this? I just keep going? No. What does a ray look like?
It's bending.
Well, I can't exactly draw a straight line, but Gracie, what is it supposed to look like?
Well, I was gonna say where I heard it from.
Okay, where did you hear it from?
Well, I heard it in some songs, like Rihanna.
Oh, okay.
Sun rays.
Oh, okay. Thank you. Chris.
Our ray has one point that doesn't move it and the other one can go on further.
Good. And we show that with what?
An arrow.
So this is what a ray looks like, right? Well, it's really similar in light. This is going to be our source of light.
A sun.
Yes, it can be the sun. We'll write sun. Or what are other forms of light that we can use?
Like stars.
Light bulbs, stars.
Fluorescent bulb.
Yes, thank you.
Good job, Eli.
And then the ray does what?
Just keeps going.
It keeps going. Just like if I were to shine a flashlight, to the back of the room, you could see that point, right? You can see where I'm pointing the light. Does that make sense? So it can travel in transverse waves. It can travel in a ray. Okay? Now I want to show you something to kind of explain this a little further with a projector. Okay. And you need a plate with water in it.
Pie.
Okay? I'm going to put it on top of the projector so the light goes through the bottom of it. In my eyes.
Whoa, I see it.
Don't get blind.
Sorry, Matthew.
Don't get blind.
That was my bad. Alright, let's try this again.
That looks better.
There we go. Can you see that?
I know.
Why is it? It's a half.
Whoa. Alright, we're going to turn it a little bit so you can see it.
That looks cool.
There we go. Okay, we gotta wait for the water to get calm. Alright, watch what my finger does. My finger is, we're pretending that it's the source of light. Okay? Watch.
Whoa.
What are the little letters?
Oh, it's just where it's made. What's happening?
It's bouncing back.
You're seeing what?
Ripples.
The waves transfer from
Your finger.
my light to what?
To the wall.
To the walls, and it's doing what?
Bouncing back.
It's bouncing back.
Well, that's really cool.
And that's actually how your eye sees things, when light hits the object and then it hits your eyes. How cool is that? If we didn't have any light, you couldn't see anything. Does that make sense?
Thank you, Tom.
You're right. He created the light bulb. Hey, Ethan, you want to come put your finger in it? Let's make a wave. Put your finger in it, and then pull it out. See? Do it again. One more time. And then pull it out. Good. Alright, that's good. Alright, one more time. Go ahead. And out. In. And out. Okay, we're done. Alright, so what is that showing us again?
That light can travel forever.
Right? Light travels in what?
It
Is that water?
Yes, it is.
And it's a type of chemical.
Light is a type of chemical?
No.
No.
It's an
Light's a
energy.
form of energy.
It'll become something that
I also have another thing to show you. Listen. So you need to be able to handle this because all the lights are going to go off and we're going to go in the back corner. Can we handle this?
Yes.
Okay, one group at a time. Group 6, can you go in the back corner, face that wall? Go ahead. Go back and face the wall. And kind of get huddled up. Go ahead. Oh, yeah, you guys need to stand. Listen, we're not. Stand up. We need to stand. Stand up, she said. Yeah, we're not sitting. Go ahead. Go ahead. 1, 2.
I got it. Uh-oh, that kind of a D on me.
We're not opening cabinets. Freeze. We're not pushing up against the wall. I said face the wall. I didn't say act like sardines when you're getting in a jar. Back up a little bit. Back up here. Back up. Back up. And we're facing the wall. You're facing the cabinet. We're facing the wall.
Oh, then I'm going over
Face
here.
the wall. That's a perfect spot.
You guys are all over there.
All right.
I see shadows.
All right. Can you see the light?
Yes.
Why can you see the light? My flashlight's over here with me. No, you're not looking at this.
Reflecting. It's like it's traveling.
And what?
It's transverse waves.
Transverse waves, and we're not making puppets. Put your hands down. Well, I'll give you a couple seconds to do that in a second. Hands down. So the light is bouncing. It's traveling from the source, which is the flashlight, right?
Yes.
And it's hitting what?
The wall.
And it's coming back and hitting your eye, right?
Yes.
That's the only reason you can see the wall right now, because if I do this, I mean, you can see, but if it was pitch black, you wouldn't be able to see it, right?
Yeah.
The only reason you can see it is because I'm shining a light on it.
Oh, we can't see it.
You will go back to your desk.
Okay.
All right, now take 5 seconds to make a hand puppet. 5, 4,
hitting your eye.
Right, it's traveling from our one source, which is the flashlight. It was hitting the wall, bouncing off and hitting your eye. That light ray was hitting your eye, telling you that's a wall, and so you can see it. Does that make sense?
Yeah.
All right, good. Now I think we could fill in. Can we fill in another part?
Yeah.
Oh, no, we haven't talked about it yet. Oh, actually, we can fill in the top part of it.
We've already
How does it travel? What waves did we just talk about?
Transverse waves.
I exited out of the.
That's okay.
Where do you get it? The math term that we talked about.
An array.
An array where it travels from one source and it's hitting.
The wall.
Yeah, it hits
wall,
whatever. Yeah,
object.
whatever is in its path.
What was in that?
But go ahead and write transverse waves in that white box where it has fast and straight. Yeah, what picture you want to draw?
We should draw
You want to write the yeah, go ahead and draw the transverse wave.
How would you draw a transverse wave?
You tell me.
Is it
I showed you on the carpet.
Well, yeah, but okay.
Just like
sound.
Yeah, it's just like sound, except they go like peak. It's just like sound.
Just like that.
More like an M.
And then write transverse wave beside it.
Oh, it'd be one.
That's okay.
Then. Oh, peak.
E-R-A-N.
Oh, yeah.
P-A-N. E-R-S-E. And then wave. Alright. How fast do you think light travels?
Oh.
What do you think? Oh, actually, I don't want to show you. Cody, how fast do you think? Go ahead and listen. Just pick a number. What do you think? So close. What do you think?
6,783 miles per
No.
186,625 miles per
Oh, did you catch the number when I put it up there? That's so close. Okay.
Yeah, you gotta.
It travels approximately, I'm just going to round this number because it's quite large, but 186 miles per second or 671 million miles per hour. And both of these are in a vacuum. How fast is that?
Pretty fast.
That's like really fast, right? So loud.
Wait, how fast can light travel through the Milky Way galaxy?
That is a great question. I will have to research that and get back to you. Does it? Yes. It takes time to travel, but it looks like it's instant, but it really does take time to travel.
Like, it takes everything.
1 millisecond.
It has the game speed.
I have a picture at the top. You can see it. This is how fast it would take for light to travel from the Earth to the Moon, which that distance is 238,000 miles.
Wait, this is correct.
It takes 1.2 seconds.
Wait, this is faster than a tornado?
Woo! What?
Is it faster than a tornado?
Yes.
Yes, by a lot.
Way faster than anything.
Wow, that is
The tornado was light.
cool. And fast.
It would be really, really fast.
And this is correct.
That is anything correct. This little yellow line that's going across is showing you how fast light can travel from the Earth to the Moon.
That is really cool.
Light sources are strong enough to reach light.
Right. It has to be like a high-powered light, like the sun.
So this thing, pretend the sun was where the Earth was.
Mhm. Yeah, that's how fast it would go.
But how do people find out this stuff?
They test it. I have seen, actually saw, I think I read this on, I have actually read online that they test to see how far planets are by sending light. So they, like when they investigated Mars, we'll say, they put a mirror to reflect the light so they can see how far the planet is, because they already know how fast light travels.
How did they know how fast?
They probably had to slow down light. sound to show you when we did the thing online on the computer.
They slowed down sound to see what the elephant
Solid.
What?
Oh yeah. On the thing, she had this thing, and then she slowed down the sound. Like she slowed it 10 times down in speed, and then she played it, and she did the.
Where?
So you hear what the animals sound.
Oh, okay. Okay, cool. So it takes 1.2 seconds from light to get from the Earth to the moon. And the sun is 93 million miles from the Earth, and it only takes 8.3 minutes for the sun's light to reach the Earth. And did you say that? Where if the sun, which is only gas, I don't know if you knew that, the sun is gas.
Yeah, chemical.
If it completely died, so I don't know really how it would do that, but if the sun died, we would still have light for 8.3 more minutes. Does that make sense?
Yes.
That was a really cool fact. I didn't even think about that.
Woo.
Yes.
How dark would it be? Like at night?
Pitch black.
Like you could.
Because the sun is the source of light for our
But would you
planet.
still live?
No. You
The
could
sun
have
is the
vegetables.
source of heat. Yes, sun. It would get really, really cold, really, really fast.
Freeze to
you
death.
like and like but you can like.
But there's no
Put
light.
the heater on. I know, but you can like.
Even if you put like thousands of clothes
You
on,
can like
you'll
run
still
into
freeze
walls.
to death. Because big time.
Okay, that's being silly. All right, so.
you can make fire.
Which that's a great question, but I don't really know that answer. I'm not what do they call it? Astrologist? Astronomist? I'm not really sure. The people that study planets. Alright, let's go fill in the last part of our square.
Wait, we never filled in
What is like
speed?
Yeah. We never did that. Wait, it was 100.
Okay, we're just going to have to write 671 million miles per hour.
Wait, so
Or
if you were going 210 miles per hour on a car, how long would it take for you to get to
I'm not sure.
200?
If you're
Not
going
sure.
60, it'll take you 1.77 years. So it would make
If a sun is made of gases, how did the gases form into that giant ball and stay shape?
That is a great
because the
question.
gravitational pull.
Maybe we could do that some research on that during enrichment.
Yeah, sun
Yeah.
is the
Big
middle.
objects have
The
planets.
sun isn't in the middle of. I mean, it is the middle of the Milky Way galaxy, but like Milky Way galaxy, I think has a gravitational pull.
Oh yeah, did you write? There are 9 galaxies.
No space, but
Right, this speed.
But if the sun isn't
9 galaxies that we know about.
yeah, that we know about.
Yeah, that we know about.
But
Commas. 000 miles per second.
Because in each
galaxy.
Do you have these numbers written down in your block?
Yes.
What is galaxy? No.
We get them written. Per second. And then
Wait, this
607.
says if there was galaxies, then how come like in scientists they
Give it to me and I'll see what I can find. I'll see what I can research. Sound good? Okay. We're gonna glue these parts. It's a question you need to write it down. In our notebooks. So go ahead and get out your notebooks. And I'm also gonna pass out your vocab for this unit that you need to also write down. It's already been pre-trimmed, so you don't need to trim any of it. We're going to come to the last block in the light column sometime later this week or next week. I know, because I said maybe next week. Yep. Please. Yeah, thank you.
Do we have to glue in this? The light.
There are 3 pages for your vocab. second and third pages for your vocab. So go ahead and get these in.
Yay! They don't want to pass it.
Oh, this is the second. This is the one after the first one. One after the first one.
We'll start here.
One after the second one. One after the second. And adding in a vacuum to your notes. Go ahead and close your book. Close your notebook. Okay. We're gonna watch a little video.
Are you gonna record the video?
We're gonna watch a little video. His voice is kind of boring. However, it says a lot of really cool stuff about life. Okay? Okay.
What else can we say about life? Well, think for a moment about some things that many of you have probably noticed. Have you ever looked up and seen beams of sunlight streaming from behind a cloud? Or walked through the woods and seen similar beams spreading out through the trees? We can think of such beams as consisting of countless lines of light. We call these imaginary lines rays. It is often convenient to think of light as traveling in straight lines, as rays. Actually, the idea that light travels from one place to another raises an interesting point. It takes time to travel. For instance, it's taken several seconds for me to walk from that tree to where I am now. A car can travel much faster. On a highway, it might travel 60 miles in an hour. Light, however, travels much faster than anything else that we know of. Scientists have calculated that light travels at over 186,000 miles per second through air or space. 186,000 miles a second. That's so fast, it's hard to imagine. Think of a jet plane that takes off from New York and flies over 3,000 miles across the country to Los Angeles. The average speed of a jet might be around 550 miles an hour. At this speed, it would take about 6 hours to complete the trip. Now let's imagine light making the same journey. At 186,000 miles a second, light could travel from New York to Los Angeles and back again over 30 times in 1 second. Light travels so fast that light from the sun, which is more than 93 million miles away, reaches us here on Earth in only 8 minutes. The stars that we see in the sky at night, however, are so far away that it takes over 4 years for the light from the closest star to reach Earth. And many stars are much farther away. Even at the incredibly fast speed of light, it takes thousands and even millions of years for the light of some of these stars to reach us.
Whoa. That's cool.
Did you learn something new from the video? Alright. On your desk, I have put sticky notes. You have pink ones and yellow ones. There's enough for each of you to have one of each color, okay? On the pink, I'll explain this in a second. Just let me write it on the board. Oh, nope. Different. So go ahead and pass them out where you each have one color. One of each.
We got 4 pinks.
Well, maybe somebody just maybe we should.
This is just a little activity so I can see what you learned and then something that you want to know or still have a question about. So on the pink, that's going to be our like you still have a question. So you need to write one question on your pink sticky note. And then on the yellow, that's going to be our aha. So something that you learned. Does that make sense? So I need one thing on each sticky note. I need a question on the pink, and then something that you learned on the yellow.
From today or just the video?
From today, and then if, yeah,
Can we
just
use
from
our
today.
notebooks?
What?
Can we use our notebooks?
Sure. That's it. Question on the pink one, and then something that you learned on the yellow one. If you can you put your name on them so I can see?
Oh.
Just so I can see. Maybe I can answer some of your questions.
How's that? Oh, should we write the names in the
Sure. Write your name on the yellow and the blue, so I know both of them are
Yellow
yours.
and pink.
Yes. Well, I said blue, yellow, and pink. Thank you.
You didn't learn anything today?
I think which one I should.
I think I gave them an
Wait. I think this might be on somebody's. Does it matter? I need a round. Or just put it.
Looking good, looking good. What's your question? What do you think?
So I have one, but yes, what? Can you make things faster if you have light?
Light is faster.
Do you like have like light and then airplane?
Can you make a plane faster?
Yeah. Yeah.
You can write that question down. Right down.
Oh, you can answer it now.
When you finish, leave the pink one at your desk, and then take the yellow one and go ahead and put it over on
The yellow side?
Go ahead and put it on the board. After you've stuck your sticky note, sit down.
Can we stick both of them?
Nope, not yet. Keep your pink ones. Gracie, keep your pink one.
No, dude, you're not supposed to put it there. Please put it there.
Matthew, if you already stuck it, sit down. Matthew.
I'm just put letter at the bottom where I can read them. No, okay, that's
No, Gracie.
Right, you can reach and then just have a seat. Good. Looks good. Alright, I want to hear some of your pink ones. That's why I had you keep them. Eli, what's your question?
Can light be absorbed?
Okay. Gracie, what's your question?
We make an airplane or like a car be faster by light.
Okay.
That's me.
What do you think, Rachel? What's your question?
But how fast does light travel around the whole world?
Oh, that's a good one. What's your question? Okay. Matthew.
Does neon colored sign on the wall count as a light source?
Does what? Say it again.
Neon colored
Count as a light source? Okay.
Is light located in the human body somewhere?
Oh, okay.
What would happen if we found a way to capture a sample of the sun's gases? Would we be able to create a new type of sun?
Good question.
Rainbow has to do with light.
Oh, what does a rainbow have to do with light? Go ahead.
What's 1 plus 1? No, just kidding. What is a diode?
A what?
A diode.
Oh, good question.
I'm a nerd that way. If the sun were to like die,
Okay.
would there be any more light left? There would be 8 minutes worth of light. 8.3
What's your
minutes.
question?
How is light made in a light bulb?
How is light made in a light bulb? Ethan, what's your question? Why? That's a great question. What do you think, Mikey? What's your question?
Can light escape a black hole?
That's a good question. What's your last question?
How did the sun become a light source?
How does sun become a light source? All right. Go ahead and stick your pink sticky note on the wall. And then maybe throughout the unit, if we can answer some of them.
Where did it go?